The purpose of this exercise is to respond to the perception of scarcity of my local lab space and to explore the potential of traditional ecological knowledge. To that effect, I chose to explore my local ecosystem, to catalog the various species and traditional uses, and to process materials towards the production of DIY bioplastics. As a designer, my background is in language and cultural revitalization for my tribe, the Tunica Biloxi tribe of Louisiana. From time to time, I contribute to tribal programming, which is done in collaboration with Tulane University in New Orleans. I also have over 6 years of experience with the International Fab Lab Network, including contributing to works on handicrafts and digital design. Locally in Boston, Massachusetts, I serve as president of the board of directors for the North American Indian Center of Boston, which is the oldest urban Indian center in the state. We provide cultural and social services for the New England Native American community. My exploration of the Atlas of Weak Signals and social interventions through the Master in Design for Emergent Futures, or MDEF, centers Indigenous futurism themes as curated in Walking the Clouds, which is edited by Grace Dillon. Building on the mapping that was done earlier in Term 1 of MDEF, I referred back to my catalog of local plants available at Jamaica Pond, which is a public park close to my home. I chose this park as it was a place of daily reflection for me while quarantining during the COVID-19 pandemic. After I took a decent sample of local plants, I researched possible uses for DIY bioplastics. I also included references for regular sources of food waste such as bananas, coffee, avocados, and onion peels. After a demonstration by Anastasia during a Fab Academy lecture, I referred to the publication The Secrets of Bioplastic. This provided a basis for equipment needs and a basic recipe to augment with a variety of materials. I further received ingredients from MDEF, including glycerin, gelatin, agar-agar, cork, and avocado pits. I did a quick audit of the kitchen setup. At first, I noticed that most of what I needed was readily available except for a kitchen scale. Instead of immediately buying a scale from my local pharmacy, I wanted to know my own options for alternatives. I found articles and web apps that act as digital scales by using 3D touch capabilities included in older models of iPhones. My personal phone uses haptic touch, which excluded that route. Ultimately, I am fortunate enough to room with a local chef, and I was able to use her personal digital scale, which I found after digging for alternatives. Once I resolved the equipment situation, I needed to decide at least one plant to work with towards making bioplastics. After finding an online tutorial on how to make red oak acorn flour, I decided to center my experimentations on the processing of acorns towards production. I harvested several pounds of red oak acorns. There were plenty on the ground at Jamaica Pond. Still, I wanted to be conscious of the food needs of the animals, so I chose to take only a few pounds. After harvesting the acorns, I took them home and cracked open the shells. At first, I did not have a nutcracker available. I did have a tool for breaking open lobster claws. This worked well. Most of the online tutorial that I found suggested slower processes such as drying the shell pieces in the sun and cold bleaching. This would take weeks in addition to the time needed for DIY bioplastic samples to dry. Instead, I used the oven at under 200 degrees Fahrenheit for several hours to dry the pieces. The result were dried acorn meat pieces with skins partially separated. I was able to fully separate the meat pieces from the skins by rubbing several in my hands. After I separated almost all of the skins from the meat pieces, I rinsed the pieces in a colander to prepare them for hot bleaching. Cold bleaching is a process of allowing acorn meat pieces to soak in a 5-gallon bucket of water while wrapped in cheesecloth. The purpose of this process is to extract tannins from acorn meat. Tannins make the acorns inedible. There is, however, a balance of extracting tannins to produce edible acorn flour as opposed to the use of tannins as resins towards the production of DIY bioplastics. I found more information in the article Tannins, an environmentally friendly ingredient for plastics industry by Christine Kelly in Advanced Science News from May 28, 2018. As I chose hot leaching of the acorn meats to extract tannins, I found an extremely sticky resin at the bottom of the pot on my first go. As the purpose of my experimentation was to first make as edible of an acorn flour as possible, I decided to discard the resin. I also did not know how to reserve the resin. Upon reflection, it would be good to repeat the process to understand the preservation and use of tannin resin. The hot leaching process took almost as much time as estimated for the cold leaching process. While less water was used for the hot leaching process, more gas was used to boil the water. So there is a trade-off in resources when making decisions to process acorn flour in terms of time, water, and gas or electricity, depending upon the stovetop and oven. Hot leaching involves bringing the pot of water to a boil and then soaking the acorn meat pieces for at least 30 minutes and then draining the water. This cycle is repeated until the drained water runs clear as opposed to a dark chocolate color. Once the acorn meat pieces were sufficiently hot leached, I smashed the pieces into a granular paste using a potato masher. It's important to mash the pieces as fine as possible as the next step is drying the paste. I dried the pieces in the oven again under 200 degrees Fahrenheit for at least 6 hours. During this time, I decided on experimenting on mashing and sifting flour from nuts, using some dried cons that were in my pantry. Once the paste was sufficiently dried, I tried sifting the flour. As I did not sufficiently mash the paste, there were still large pieces. I used a blender to grind the pieces and sifted until I had a sufficient amount of flour to use for bioplastics production. Using the main recipe from The Secrets of Bioplastic, I experimented within the 48 grams of gelatin powder using different ratios of ingredients. This included blends of acorn flour, gelatin, agar-agar, cork, and avocado pits. Each mixture was combined with 240 milliliters of water. Once a paste formed, each was placed over a medium-low flame to which was added 12 grams of glycerin. I used the top lids of plastic takeout containers as molds. I placed each of the molds on top of a bookshelf and left them to dry. The apartment was heated during colder temperatures, so I suspected a high place would be good for drying. Originally, I covered the blends with plastic wrap. As condensation formed on the wrap, I decided to uncover each mold and leave them to dry for at least a week. In order to do this experiment, I tried several shortcuts which were intensive on water and gas to conserve time. Ultimately, this process could take at least a month to produce the flour and sufficiently dry the DIY bioplastic samples. Furthermore, more experiments are needed to test tannin resin use within the bioplastic samples. This question would be whether less leaching is better to retain tannins within the meat, or whether tannin resin can be conserved to be added back into the DIY bioplastics. Further, if the resin can be added back in, would this impact the ratio of glycerin in the mixture? The most successful samples from these experiments were combinations of gelatin and avocado pits or acorn flour. The blend of agar-agar and acorn flour proved somewhat successful as the material shrank and curled in the mold. Other blends cracked as they dried. In any case, I learned much more about my local surroundings and established an ability to harvest plants towards DIY bioplastic production.